Hi, we're going to pick up with part 2. PowerPoint is loading. So we've got mixtures. We just finished talking about pure substances. These are mixtures. Now, a mixture doesn't have a definite composition, no set formula. Ratios can vary. It's very different than something that's pure. Mixture is going to have more than one thing there. We have two different types. We have a homogeneous mixture, which is two or more elements or compounds evenly mixed. It's the same throughout the sample. Best example is salt water, which we have right down here, NaCl aqueous. Another fabulous example is air. When we take a sample of air, we look at air, we can't tell where's the oxygen, where's the nitrogen. I'm looking around the room, I can't see each. It's a homogeneous mixture. It's the same throughout. Now, when it's liquid mixed with a solid and we can't tell, another word for it is solution. Now, all mixtures can be broken down separately or physically. Key word, they can be physically broken down. Okay, the other kind is a heterogeneous mixture. A heterogeneous mixture, same again, two or more elements or compounds unevenly mixed. Unevenly, meaning we can tell the difference. Now, a great one is sand and water. Here I've got sand, salt, and water. When you go to a beach, does the sand mix into the water? It does not. So if I put in a beaker sand and water and salt and mix it up, your sand is going to be on the bottom and your salt water is going to be on the top. Yes, your sand will be wet, but primarily it'll be sand at the bottom with a little bit of salt water mixed in just to make it wet. Definitely different, heterogeneous. I can see them in different places. Now, one of the things we're going to be getting into, and I'm going to move me, is elements versus compounds. Now, elements are pure. There's 118 of them. It's very easy to figure out if it's an element. There's only one there. They all have the same properties. Every element of sodium is exactly the same property. Remember, we do have some that are diatomic, and I've got something in the bottom that's making it hard to see our examples. Let me press present again. And it's still not letting me. Sorry about that. I'm just going to escape out of there so you can see it. Some are diatomic. Now, our other one is compounds. And here are examples of elements: boron, magnesium, oxygen. A compound is pure. Pure meaning we have two or more different elements chemically combined. It's the same throughout. An example would be NaCl, which would be table salt, MgO, magnesium oxide. And then our other is mixture. Two or more different elements and or compounds physically combined. So we're going to mix that salt in the water. Now this is just an overview of what you did on the last two slides. Okay? And we're going to get into types of compounds next. Our types of compounds, here we go. We have three, and we're only going to write down so we can recognize where they are on the periodic table. An ionic compound is a metal ion and a non-metal ion. So we're taking something from one side of the table and combining it with something from the other side of the table, and we get an ionic compound. A covalent compound is only nonmetals. And it's going to be different nonmetals. Remember, it's not just an element, it's a compound. So carbon dioxide, we have carbon and oxygen. Water, we've got hydrogen and oxygen. Metallic is our third kind. Two metals. They usually don't react, but they do form mixtures, and those mixtures are called alloys. Okay, there are a couple links at the end of here. It's our Discovery Ed textbook, our interactive periodic table, which you've dealt with before. And there is an EdTed periodic video if you want to watch. It is not required, but I do want you to finish your note packet. I want you to try the last page, the graphic organizer, and see how you do.